Well, welcome back to our final session of our 23rd Annual Pollution Prevention Virtual Conference and Trade Show. We're really glad you're with us this afternoon. My name is Julia Wickard, for those of you that may be joining for the first time, and if not, you're really tired of me saying my name. But I serve as the Assistant Commissioner and the Agricultural Liaison with the Indiana Department of Environmental Management. And I have so much enjoyed being the host for this 23rd annual Time Around the Sun for this conference. I work very closely with our P2 group here in IDEM, and also with our partners executive committee who are hosting this conference. So no matter how much time you shared with us over the last 2 days, we really appreciate you making our conference and trade show a part of your week and a part of your fall conference attendance. We'd want to remind you one last time that if you would like to share about the conference, which we would love for you to do so, if you could just use the hashtags that are on the screen, hashtag small changes, hashtag big impact, and hashtag pollution prevention when talking about the trade show and any of our speakers. We'd really appreciate that. So yesterday and then this morning, we've had the opportunity to learn a whole lot. And hopefully you have had some time to visit our exhibitors in our virtual trade show on our remote platform. You'll have one additional opportunity following our session today. So now we're going to focus and reshift our attention to aeration and energy savings. But before we dive in, just a few logistics overviews that I want to give you. This session is packed full of CEUs for wastewater, so we would just ask that you refer back to the conference packet that was provided to you prior to the conference on how to submit those CEUs. We want to make sure that you do get credit for attending. I will be sharing with you and introducing our speakers for this afternoon. They will present their pre-recorded sessions, and then they will come on live and be with us live to answer your questions and answer. In the lower screen below you, there is a Q&A box where you can type in your questions as you're thinking of them, and they'll be banked, and then we will have a live moderated session. So I'm serving as the live moderator for the conference, and we are recording this virtual conference. We've recorded all the sessions, and they will be available for your viewing pleasure after we're done. And we have a conference survey link that will be going out, an email with a survey link that will be going out today after the conference. You're going to have about a week to get back with us on your comments, your feedback, your suggestions, the things you liked, maybe things you didn't like, things that you change. We hope you liked everything, but we are always looking to improve our events. And so we'd love to have your feedback. We'd love to have your ideas for future topics for our future conferences and quarterly meetings. So that's really important. This slide talks about our sponsors, and we could not have made these last 2 days happen without our conference sponsors. So our gold sponsors for the final time are Caterpillar, Lilly, NEI, Elysian, Roche, and Evonik. And our silver sponsors are Allison Transmission and AstraZeneca. And you know the routine, and I'm going to do this one last time as well, but it's really to send a huge shout out to our behind the scenes wizards. Jennifer Collins, Kristen Coasters, and Jean Fix have been instrumental in making this event happen. There is a lot of activity happening behind the scenes and in chat and text messages to bring this conference to you in a live moderated session, but to make sure we're ready to play videos and we're ready to share information. And so I would really like at this time for Jennifer and Kristen and Jean to come on, give a wave so you can see them face to face and help me in thanking them for their excellent work. So I see there's Kristen, ready to see Jean. Let's give him a hand. Thank you, ladies. You guys have been great. Appreciate everything you've done and will continue to do for this subject matter for the future. So we really appreciate your work, and on with the show, right? So again, this session's topic is water, and specifically aeration and energy savings. Michael Kuss is the general manager of the Michigan City Sanitary District. He has a Bachelor's of Science degree in chemical engineering from Tri-State University in Angola, Indiana. The Michigan City Sanitary District consists of water reclamation, stormwater, and refuse departments. Mr. Kuss has held this position since 2012. Prior to this position, he worked for the Indiana Department of Environmental Management as an environmental engineer for 26 years. He has a Class D industrial and Class 4 municipal wastewater treatment operator certification. Please help me in welcoming Michael to the P2 conference stage for his pre-recorded video presentation.
Good afternoon, everyone. My name is Michael Kuss, General Manager at the Michigan City Sanitary District in beautiful Michigan City, Indiana. On the southern shores of Lake Michigan, the Great Lakes, the largest body of fresh water in the world. I'm very excited to present today at the 23rd Annual Indiana Pollution Prevention Conference and Trade Show. My presentation is entitled Aeration and Energy Savings, Making Small Changes Provides Big Impacts. This presentation will focus on the activated sludge type wastewater treatment facility. It is a technical presentation designed to provide continuing education credits for certified operators. There will be a considerable amount of math and calculations in this presentation. But first we must ask, what is the most important aspect of any activated sludge type facility? Proper and adequate aeration. Making small changes in the aeration supply can provide big savings in energy costs and huge reductions in pollution. Is this a simple, straightforward process? I've heard turning down the aeration will save big money. So I turned it down, way down. I should start seeing savings soon. After I save all this money, maybe I'll get a raise. Unfortunately, it's not that simple. Without the proper amount of aeration, this is Mr. Big. Mr. Collins often talks about Mr. Big when he gives his presentations at the Pollution Prevention Conference each year. And as Mr. Collins will remind you, Mr. Big will not be happy with you if you turn down the air too much in your aeration tanks. You will be receiving a call from Mr. Big, and he will be saying to you, "Hey, Michael, what do you know about these permit limit violations?" I don't think anyone wants to receive that call from Mr. Big. And without the proper aeration, the overall objective of treating the wastewater will be compromised, polluted water will be discharged to the receiving stream, and violations of the environmental rules will occur. And you can be rest assured, Mr. Big will be on the other end of the phone. Let's spend a little time to talk about the activated sludge process. The activated sludge process is a process for treating sewage and industrial wastewaters. The process was developed around 1912 to 1914. It mimics what occurs naturally in nature, but vastly speeds up the process so that clean water can be discharged safely to our rivers and streams. There are a large variety of designs. However, in principle, all activated sludge systems consist of three main components: an aeration tank, which serves as a bioreactor, a settling tank or a clarifier for separation of the activated sludge solids and the treated wastewater, and a return activated sludge equipment to transfer settled activated sludge from the clarifier back to the influent of the aeration tank. This is a diagram of the basic activated sludge system, and as you can see on the left is where your raw water enters into the aeration tank. The red arrow coming down illustrates the air that is used in the aeration tank. From there, the wastewater flows into the clarifier/settler, where the biomass that's created in the aeration tank settles, and the treated wastewater is discharged to the receiving stream. And then at the bottom of the clarifier, you have your return activated sludge that goes back to the beginning of the aeration tank. And then you have your waste activated sludge or your waste sludge, which goes to sludge treatment for further processing. The biomass mixture in the aeration tanks is commonly known as mixed liquor. Typically, the solids range between 2,500 and 6,000 milligrams per liter in these tanks, and you want to maintain a dissolved oxygen level of at least 1 to 2 milligrams per liter at the end of the tank to achieve adequate treatment. Efficiency is controlled by your detention time in the tank and other factors like your loading of BOD and nitrogen. That's called your food to mass ratio or your food to microorganism ratio. And of course, your oxygen supply. Here are a couple pictures of blowers that are used in the activated sludge process. On the left are some positive displacement blowers, and on the right are some turbine blowers. But how much air is needed to treat the wastewater? Let's take a look at the theoretical oxygen requirements. The blowers are used to supply air, but more specifically oxygen to the biomass. The theoretical amount of oxygen required can be calculated using the flow, BOD, and ammonia loadings. The theoretical oxygen requirements are contained in the 10 state standards. It's a policy for design, review, and approval of plans and specifications for wastewater collection and treatment facilities. Here are a couple copies of the 10 state standards, and you might note that the states that are included are Illinois, Indiana, Iowa, Michigan, Minnesota, Missouri, New York, Ohio, Pennsylvania, and Wisconsin. Those are your 10 states. If you look at the 1978 edition on the right, you can see that it had 10 states, hence the name 10 state standards. However, the 2014 edition, the province of Ontario, Canada, got into the mix. So we still call it 10 state standards. IDEM uses this to review your plans and specifications for your new treatment facilities. And even though there are actually 10 states in one province, they still call it the 10 state standards. The theoretical oxygen requirements are contained in section 92.331, and they state that 1.1 pounds of oxygen are needed for every pound of BOD treated, and 4.6 pounds of oxygen are needed for every pound of ammonia treated. Air contains 21% oxygen. 1 cubic foot of air equals 0.075 pounds, and there are 1,440 minutes in a day. A fine air diffuser has an efficiency rating of about 12%, and a coarse air diffuser has a 4% air efficiency rating. Why does fine air have such a higher oxygen transfer and efficiency rating than coarse air diffusion? Surface area of the bubbles, of course. Hundreds and thousands of small bubbles have more surface area than a few large bubbles. The more surface area, the more oxygen transfer with the organisms, and the more efficient the process. Other more detailed information such as temperature, depth of water over the diffuser, humidity, barometric pressure can also be used to refine these calculations. Let's look at an example. Our example wastewater treatment facility will have an average daily flow of 12 million gallons per day, an average BOD loading of 200 milligrams per liter, and an average ammonia loading of 20 milligrams per liter. How do we calculate the daily pounds of BOD and ammonia? We calculate these pounds by taking the flow in million gallons per day times the concentration in milligrams per liter times a conversion factor of 8.34. So looking at our example, we have the pounds of BOD is 12 million gallons per day times 200 milligrams per liter times our factor of 8.34 we end up with 20,016 pounds of BOD per day. For nitrogen, we use the same calculation and we end up with 2,002 pounds of nitrogen per day. And the amount of oxygen that we need is 1.1 times the 20,016 plus 4.6 times the 2002, and that equates to 31,225 pounds of oxygen we need every day. So as you can see, we need a lot of oxygen to treat this wastewater for 12 million gallons of flow. Remember, 1.1 pounds of oxygen is needed to treat the BOD, 4.6 pounds of oxygen is needed to treat the ammonia. So our wastewater treatment facility that needs 31,225 pounds per day of oxygen. How do we calculate how much air we need? To determine how much air we need for the day, we take our 31,225 pounds per day requirement of oxygen and we divide that by 0.21, because remember, air contains 21% oxygen. This means we need 148,690 pounds of air to treat our wastewater. And to put that in cubic feet per day, we divide that by the factor of 0.075, because 1 cubic foot of air weighs 0.075 pounds, which yields us 1,982,537 cubic feet of air is needed each day to treat our wastewater. Let's remember, the coarse aeration has a 4% efficiency transfer rating, and the fine aeration has a 12% efficiency transfer rating. Using these factors and our 1,982,537 cubic feet per day, we can calculate that we need 34,419 cubic feet per minute of air if we use coarse diffusers. Using a fine diffuser, we can calculate that we need 11,473 cubic feet per minute per day. As you can see, the fine aeration diffuser is 300% more efficient, or the coarse aerator uses 300% more air than the fine air. And if you have coarse aeration in your facility, significant waste of energy, you should be changing it out to fine aeration diffusers as soon as possible. And this will significantly save energy, and it will reduce air pollution at the same time. We must also remember that the blowers that are used to supply air to the aeration tanks are often used to supply air to other processes in the wastewater treatment facility. In our example facility, we will use 396 cubic feet per minute of air for post-aeration. Therefore, the total amount of air that our blowers need to supply at design loading is 11,869 cubic feet per minute. Let's take a minute or two to discuss the difference between actual airflow rate, or actual cubic feet per minute, and standard condition airflow rate, or standard cubic feet per minute. We all remember from school the ideal gas law. It starts out with Boyle's law, which states pressure of a gas is inversely proportional to its volume. Robert Boyle noticed that when the volume of a container holding an amount of gas is increased, the pressure decreases, and vice versa, provided that the temperature is held constant. And Charles' law states a volume of gas is directly proportional to its temperature. Scientist Jacques Charles noticed that if air in a balloon is heated, the balloon expands. Mathematically, we can combine Boyle's law and Charles' law into pressure times volume divided by temperature equals a constant. The ideal gas law combines these relationships between pressure, volume, temperature, and mass, and gives us a number to the constant. The ideal gas law is PV equals nRT, where N is the number of moles and R is the universal gas constant. The value of R depends on the units involved, but it is usually stated with the SI units as R equals 8.314 joules per mole per degree Kelvin. Now, some of you may wonder why we're going over all these laws: Charles' law, Boyle's law, the ideal gas law. This is a requirement of the continuing education for the Partners for Pollution Prevention, because there are a lot of attorneys that attend this conference each year and trade show each year, and they need to make sure that they get their continuing education credits also. So we try to work in these little aspects here and there about these different laws. Actual cubic feet, ACFM, is a unit of flow rate. It is commonly used by manufacturers and blower compressors. It's the actual air that is delivered. Standard cubic feet per minute is a volumetric rate that is corrected to standard conditions. But here's the tricky part. The standard conditions may vary depending on the standard used. The International Union of Pure and Applied Chemistry and the National Institute of Standards and Technology have different standards. To make matters worse, the IUPAC actually changed their standard definition. Until 1982, they used 0 degrees Celsius and 1 atmosphere. However, after 1982, they started using 10 to the 5th pascals, or 1 bar, instead of 1 atmosphere. And the NIST uses a temperature of 20 degrees C, 297.15 Kelvin, or 68 degrees Fahrenheit, and an absolute pressure of 1 atmosphere. International standard and metric conditions are also provided here. Here's a table that I put together that shows the difference between standard cubic feet per minute and actual cubic feet per minute. And as you can see across the top, we have the same temperature, we have the same pressure, but we have different temperature. The temperature increases from 130 to 200 degrees Fahrenheit. And as you can see, as the temperature increases, the actual flow rate increases. If you look from the top down, you see where you have the pressure of 7 psig and 14 psig, but the temperature stays the same. So as the pressure increases, the actual flow rate decreases. Same with the 200 degrees. As the pressure increases, the actual flow rate decreases. And remember, when you're measuring something with a gauge, a pressure gauge, you're not measuring the absolute pressure, you're measuring the gauge pressure. And if you're measuring 7 psig gauge, that's actually equal to 21.7 psi absolute, because the atmospheric pressure is 14.7 pounds per square inch. Every day we walk around in our lives, we're being pressurized by 14.7 pounds per square inch of air. How do we measure airflow? This is typically done through a venturi, or a restriction in a tube. The top is just a basic drawing that air flows in, there's a restriction, and then the air flows out. And what you do is you measure the pressure differential across the restriction. There's some pictures of a couple venturis. And here's the calculation for calculating the flow rate through a venturi. And one of the factors is this Y factor here, which is your adiabatic expansion factor. And we'll take a look at that equation in and of itself. Some simple math. If there's any mathematicians here at the conference, we'll be glad to look at that. But what you do is you have your manufacturer print you out a table that provides you with the actual flow rate and your pressure differentials. While it is important to understand the difference between the actual flow and your standard flow, we will stick to cubic feet per minute for this presentation, and I will let you calculate your actual flow at your own facility. We will also elaborate more on the venturi flow rate calculation in a sequel to this presentation. Back to our example. At theoretical design, the total air required using a fine air diffuser is 11,869 cubic feet per minute. Remember, the total cubic feet per minute includes the amount of air needed for the post-aeration. At our example facility, there are 6 blowers. They are labeled blowers 1 through 6. Here they are on a table. Here's their capacity per minute. We have 2 blowers that can discharge 3,700 cubic feet per minute, one that can discharge 1,840 cubic feet per minute, one that can discharge 11,400 cubic feet per minute, and 2 that can discharge 2,300 cubic feet per minute. So we have a current capacity, a total capacity of 14,980 cubic feet per minute, and a firm aeration capacity, talk a little bit more about that, but a firm aeration capacity of 11,280 cubic feet per minute. Firm aeration capacity is defined as the capacity available with the largest unit out of service. Think about this. If you're designing a wastewater treatment facility or a lift station, you need to have redundancy. And the redundancy that you need is based upon with the largest pump out of service, or in this case, the largest blower out of service, or largest treatment unit out of service, can you still meet the design criteria of the facility? So here we have a situation where at our example wastewater treatment facility, when we take off the largest blower, which was 3,700 cubic feet per minute, we end up with 11,280 cubic feet per minute of firm aeration capacity. Does this firm aeration capacity, does our example wastewater treatment facility have enough firm aeration capacity? Yes or no? The answer is no. The total air required, again, was 11,869 cubic feet per minute, but our firm aeration capacity is only 11,280 cubic feet per minute. Here's a little tip for any IDEM wastewater treatment inspectors that might be listening in to this presentation. It's something you should check when you check your wastewater treatment facilities to make sure that if their largest aerator is out of service, they have enough firm capacity to treat their design load. Most wastewater treatment facilities rely on fine bubble air diffusion for both the necessary oxygen treatment and the necessary air for mixing. Please understand that in the aeration system, it must be well mixed. It's not a matter of just entering this air in there in the corner, one little spot or two little spots within the aeration tank. It has to be mixed, well mixed throughout the aeration tank so that the proper oxygen transfer and the microbes can feed off of this air. Adequate mixing is very important. The manufacturer of the fine aeration diffuser system at our example wastewater treatment facility recommends 0.12 cubic feet per minute of air for every square foot of aeration surface area. The surface area of our example wastewater treatment facility of the aeration tanks is 36,000 square feet. Multiplying this 36,000 times 0.12, we get a factor of 4,320 cubic feet per minute. The total minimum amount of blower airflow needed for proper mixing is then 4,320 cubic feet per minute, plus let's not forget our 396 cubic feet per minute that we need for post-aeration. So in order for our example facility to have enough air for proper mixing, we need 4,716 cubic feet per minute to provide proper mixing. Is the air required for treatment at average design loading, at the average design loading, is there enough air to provide adequate mixing? Yes or no? Yes. The air needed for design is 11,869 cubic feet per minute, and the air needed for mixing is 4,716. So it can be seen that if we have the design airflow going through our aeration tanks, we have more than enough needed for adequate for mixing. At design, that's the key, at design. Why is proper mixing so important? The last thing any certified operator of an activated sludge treatment facility needs is undesirable organisms, such as filamentous and a Narcardia. These organisms can cause severe operational difficulties that will lead to violations of the NPDES permit and long-term operational difficulties. And let's not forget a call from Mr. Big. Many of these undesirable organisms thrive in low DO conditions that can be present in poorly mixed portions of the aeration tanks where the DO will be lower. I cannot stress this point enough. You do not want to have an inoculation of your treatment facility with Narcardia or filamentous. Actually, Narcardia is a type of filamentous. You do not want to have this in your facility. You will battle this for months, maybe even years, in order to rid your facility of this problem. This is why adequate mixing is so important. Here's some pictures of what filamentous bacteria looks like. It's like a hair-like substance that really slows down your settling. And when you get the Narcardia, it'll make a foam in your aeration tanks, and it will cover your aeration tanks, and you will be upset for sure. And it will likely lead to permit limit violations and ultimately a call from Mr. Big, Mr. Collins' friend, Mr. Big. The call you do not want to receive. Next, we will look at the actual loadings to the wastewater treatment facility. We looked at the average data for a 3-year period of our hypothetical wastewater treatment facility located in Michigan City, Indiana. The flow for the 3-year period on average was 6.8 million gallons per day. The average BOD loading was 75.27 milligrams per liter, and the average ammonia loading was 14.32 milligrams per liter. Using this criteria, we calculate that the average loading per day was 4,269 pounds of BOD, 812 pounds per day of ammonia, and the oxygen needed using the 10-state standards of 1.1 pound of oxygen for every pound of BOD and 4.6 pounds of oxygen for every pound of ammonia calculates to 8,431 pounds per day of oxygen are needed to treat the average flow at our hypothetical wastewater treatment facility. The amount of air that is needed, we take this 8,431 pounds per day and divide that by 21%, which is the amount of oxygen in the air. That yields us 4,139 pounds per day of air is needed. And using the 1 cubic feet of air weighing 0.075 pounds, we could see that we need 535,322 cubic feet per day of air. And you might remember that compares to the 1,900,000 cubic feet of air that we needed at the design criteria. For fine air diffusion, taking the 535,322 cubic feet of air and the fine air efficiency rating of 12% and the number of minutes in a day, we can calculate that we need 3,098 cubic feet per minute of air for our wastewater treatment facility. We need to add the 396 cubic feet per minute that we need for post-aeration. So on average, to treat the average daily load at our wastewater treatment facility, we need 3,494 cubic feet per minute of air. Remember, we need 4,716 cubic feet per minute of air to meet the minimum mixing requirements. It can be seen that on average, the minimum amount of air needed or required is not based on the oxygen demand or the loading to the treatment facility, but instead on the amount of air that is needed for mixing. A further study of this data showed that on 92% of the days in the 3-year period, the wastewater treatment facility was limited by mixing and not by the amount of air that was needed to treat the average daily load. Now we need to think about daily and intradaily fluctuations. What is the day with the highest loading? Dissolved oxygen sags and heavy loading occurs routinely. Typically, the wastewater treatment facility will see high dissolved oxygen demand for several hours a day and low dissolved oxygen demand for extended periods of time. There's a diurnal effect in your wastewater treatment facilities, especially your municipal facilities. You will have a time of the day when you're going to get your peak loads and your flows will increase and your loadings will increase. At our facility, this usually happens in the afternoon. Between noon and 7 p.m. is typically when our loads will increase and our aeration system will need more air. Therefore, on average, the wastewater treatment facility might be limited by mixing, but for several hours a day, more oxygen or air might be necessary to keep the aeration tanks from going septic. When choosing a blower, when choosing a new blower, you need to make sure that it has enough capacity to meet your peak demand when your heavy loads come in during the middle of the day. And you also want to make sure it has a wide operating range so that it can be turned down when the demand is low. The old school method was constant airflow at design or worst case scenario, the new technology, many wastewater treatment facilities now use DO meters in the aeration tanks to control and regulate the airflow to the aeration process. These meters are typically connected to the blowers and sometimes to valves to increase or decrease the airflow as necessary to the aeration tanks or to certain aeration tanks. There's a picture that shows the activated sludge process again with the DO meter measuring the DO in the aeration tank, sending the signal back to the blowers. As the DO starts to drop in your aeration tanks, the airflow of your blowers will need to increase. As the DO in your aeration tank rises, the airflow in your airflow from your blowers can be turned down. Is there another way to accomplish this control, but still to achieve proper mixing? Yes or no? The answer is a definite yes. You can install mechanical mixers. Using mechanical mixers in the aeration tank, proper mixing can be achieved, and the blowers can operate at a lower speed using less energy because you will not have to worry about having that minimum amount of air for mixing because your mechanical mixer will provide the necessary mixing. But of course, in any evaluation like this, you need to evaluate the cost of the mixers, the energy usage of the mixers, and the required maintenance of the mixers must all be factored into the decision to use mechanical mixers. You'll typically find they will use less energy. The cost is usually quite high, and your maintenance, you don't want to have to be pulling those out every couple of years and buying new ones. So that's what you need to look at if you want to look at mechanical mixing. One other point about changing your blowers from old positive displacement blowers to new turbine blowers are the occupational health and safety benefits. These new turbine blowers are so quiet, they're really quite amazing. You could stand right next to them and have a conversation at normal voice level, where the old positive displacement blowers, if you're standing next to those when they're running, it's so loud you can hardly hear yourself think. Now let's talk about energy savings and pollution prevention. Based on actual operations, not design, the current positive displacement blowers of our mythical hypothetical wastewater treatment facility uses 277.5 kVA or kilowatt hours. The proposed turbine blowers that we are considering installing will use only 179.6 kilowatt hours to produce the same amount of air needed for the treatment facility. How much energy will be saved, and what are the pollution prevention benefits? The utility rates we will use are $24.30 per kilowatt peak demand per month and 5.4 cents per kilowatt hour of usage. To calculate the demand savings, we take the kilowatt hours of the proposed new blowers and subtract that from the kilowatt hours of the existing blowers and multiply that by our $24.30 per kilowatt hour. That yields us $2,379 per month in demand savings, and multiplying that by 12 months per year, that yields us $28,548 per year in demand savings. To calculate the usage savings, we take the kilowatt hours of the current system and multiply that by 8,760 hours per year. Those of you with an air permit are certainly very familiar with this 8,760 hours per year figure. That yields 2,430,900 kilowatt hours per year. The proposed usage times the 8,760 hours per year yields 1,573,296 kilowatt hours per year. Subtracting those two numbers and multiplying the difference by 5.4 cents per kilowatt hour yields a savings of $46,311 per year. The total energy savings is the addition of the demand savings plus the annual usage savings. 28,000 plus 548 plus 46,311 yields $74,839 per year of electrical energy savings. Here is the information presented in a table format. I have this table in Excel. Be glad to share it with anyone that would like it. Just drop me an email or give me a call and I'll send it to you. Shows the same information. All you'd have to do is plug in your actual current operating values, your kilowatt hours, and your proposed kilowatt hours. Make sure you have the correct demand charge and usage charge. And as you can see, you will calculate at the bottom your savings, in this case again, $74,858. The point I want to make also about this is this shows the annual reduction in energy of 857.604 megawatt hours. The U.S. Energy Information Administration, or the EIA, has information on Indiana's electricity profile, and for every megawatt hour it results in emissions of 3.3 pounds of sulfur dioxide, 2.1 pounds of nitrogen oxides, and 1,883 pounds of carbon dioxide. Using the 857 megawatt hours of energy use reduction times the pollution emission factors, it is shown that the project will reduce sulfur dioxide by 2,830 pounds per year, nitrogen oxides by 1,801 pounds per year, and carbon dioxide by 1,615,000 pounds per year. So not only do these energy savings projects help out the pocketbook, they are also fantastic for the environment. I would now like to go back to last year's conference, pollution prevention conference, and talk a little bit about partnerships. As I explained last year, partnerships are the key to environmental sustainability and pollution prevention. A partner is a person who shares or is associated with another person in some action or endeavor. Nothing depicts that better than the handshake. You know, if you can make a handshake agreement with somebody and trust them, you know they're a true partner. In Michigan City, our partners for our energy savings project were the Energy Service Group, NIPSCO, and DLZ Engineering. From the information presented in this presentation, it can be seen that making small changes provides big impacts. And I'm now available for any questions that anybody might have.
Thank you, Michael. We really appreciate your presentation and focusing on energy savings and what you shared with us today. It was very informative. As Michael indicated, he is available for question and answers, and we do have questions in the queue. And at this time, would ask that you just go ahead and type your questions into the queue if you have questions. I'm going to turn it over to Jennifer Collins, who is our manager for our Pollution Prevention and Compliance and Technical Assistance Program here at IDEM, and she's going to moderate the Q&A. So I'll turn it to you.
Thank you, Julia. And thank you, Michael, for your presentation. We really appreciated all that you shared with us. We do have several questions that came in during your talk. And so I'll just start here. What are the other factors to consider when determining a switch from coarse to fine aeration? For example, does fine cost more, require more frequent change out, maintenance, require other equipment change outs, etc.?
That's a good question. There is a little more maintenance sometimes with the fine air. They can clog. There's various types. There's like a rock media that like I might have said in the presentation, it kind of something they might like seeing your aquarium at home. And we typically clean that about once a year using a very diluted acid solution. And when we do that, we also certainly monitor our pH at our final effluent. We've never even seen it change the pH, but it clears it out a little bit. There's also a rubber membrane type that also needs some periodic maintenance, but the maintenance that you would perform on those would be the savings, excuse me, far outweigh any of the maintenance. One of the other things to consider at our particular treatment facility, we actually have, and we still have, both coarse air and fine air. When our facility in the 80s was upgraded to use the fine air, it was relatively a new technology, and the company that manufactured the fine air was concerned about mixing the horizontal mixing as the wastewater passes through the clarifier or through the aeration tank. So that's why they wanted the coarse air. Personally, we had a lot of struggles with our operations team and just some folks that had been here for a long time. They really didn't want to turn off that coarse air, but we did some testing with some sludge judges and different things to make sure we weren't getting any excessive settling when we turned our clarifiers down to what we felt was the minimum we needed for mixing. So it seemed to work pretty well. But like I said, and I stressed in the presentation often, is, you just want to make sure you have that proper mixing. It's just such a key. And I know our engineer, Bill Boyle from DLZ, when we started working with him, first time I talked to him on the phone, he pointed out to me that almost all wastewater plants are more mixing limited than they are oxygen demand limited here in Indiana, at least. So that's something I just think everyone needs to keep in mind. And a lot of people, when they start with this, a lot of engineers just want to talk about that DO demand all the time.
Great.
Hope I answered the question.
Thanks for your answers. Yes, those seem to address that question. I think that this question was possibly just answered by one of your slides when you said that the use of fine aeration will also decrease air pollutant emissions. Can you elaborate on how air emissions are decreased? You're talking about the energy that is reduced and going back to the power plant.
Sure. I really enjoyed Linda's presentation that she provided, and I noticed she made the comment about trying to keep it down so you can fit it into the time frame. And as I was going through this presentation, I kept saying to myself, I never really made that connection, and I was going to go back and add some more slides in, but I thought I was already past the 35 minutes that you asked me to keep it to. But certainly it's a good question and needed to be said. Is that when you're using the energy, the power plant is producing the energy, and in our case, of course, it's a coal-fired power plant. And when you're using that coal to make the energy, that's where you get the pollution from those emissions, and that's what we're talking about, is protecting the environment by using less energy, because, of course, the coal-fired power plant puts out the pollution that I described in that one slide where I had those emission calculations. For those of you that don't know, in Northwest Indiana, or at least Northern Indiana, I should say, NIPSCO is the main electrical provider up here for most folks. There are a few others, and they are pretty much committed to closing down all of their coal-fired power plants, and I think they're going to try to go maybe even totally solar. So those calculations may not prove to be as prudent down the road, but certainly that change would be better for everybody. Yes.
And I think that she also added to that question, and I think you just addressed that with that your power comes from coal combustion.
Yeah, sure. Yeah. And that's another thing to look at. Notice you had the natural gas. If you've got a natural gas fired power plant, certainly those emissions are going to be a lot less. As I know, we've been a real proponent of the natural gas vehicles. I think we have 10 compressed natural gas vehicles that we're using now here at the Michigan City Sanitary District. And, that's another thing I would like to just, if I could, just take a second and make a plug for the Partners for Clean Air. Northwest Indiana Partners for Clean Air, which the Sanitary District is also a member of the Partners for Clean Air. And I would encourage anyone else that's listening to this presentation or that's a member of the Partners for Pollution Prevention to really think about joining the Partners for Clean Air. It's a very good organization. Much like the Sanitary District, we also are much like the Partners for Pollution Prevention. We also started giving away some scholarships this year, which seemed to work out real well. So just wanted to put that plug in if I could too.
Yes, thank you. We love that organization as well. And she also asked, are there any other pollutant reductions achieved by the change in the process?
Well,
other than reduce the energy use?
The reduce of the energy use is certainly the biggest key. You know, there are other reductions by less maintenance. So if you have less maintenance, you're actually having less waste, you know, those types of things. That's one of the big things with the LED lighting. I didn't get into that in this presentation because this was more about the aeration. One of the things I was really trying to do in this presentation was to focus on some of the math, because when our operators a lot of times go to take the test, the certification test, a lot of times they struggle with the math portion of it. So it's been something that I've tried to focus on in some of my presentations over the last few years, and wanted to show some of those calculations. But when you just look at energy savings, when you look at the LED lighting, of course, one of your biggest savings is just your maintenance of not having to replace the lighting so often and those types of things. And certainly the same thing with the blowers. We don't have to grease the turbine blowers. You know, they have these particular ones that we use at our facility have actually a magnetic bearing, so there's no greasing that's involved. You're not changing belts and things like that. So there's a lot of added savings there, pollution reduction savings there. And of course, with just going with the fine air treatment, you just get really, really excellent treatment and reduces the discharge of pollutants to the stream.
Okay, great. And one other question here. Is it possible and or recommended to use a combination of fine and coarse diffusers so that the benefits of both methods can be achieved while minimizing the drawbacks of exclusively using
certainly.
one type?
You certainly can. Like I mentioned that our facility had done that for 20, 30 years, quite frankly. And it was something that we really had to fight hard to try not to use the Corsair. But the problem with the Corsair is, you know, every time you put a cubic foot of air out there, you know, like I said in my slide, you know, you're basically wasting 300% of it because you just don't get the mixing, but you don't get the air transfer for the treatment. But you still get some treatment. Don't get me wrong. You still get some treatment, and you need to take that into consideration. But definitely, you could definitely use both. You know, it's really not really energy efficient or cost effective to really use both. Probably a more appropriate thing to really look at if you wanted to do an analysis would be the mechanical mixers. Mechanical mixers they use very little power. You know, you can get 1 horsepower or half a horsepower mixers. The biggest problem with the mixers, like for our facility, when we looked at installing them, we were looking at $500,000 just to install mixers. And it was like, that doesn't seem right. Maybe we could have gotten it done cheaper, but also your maintenance of it, there'll be a lot of rags and stuff that'll get caught up on it. So you have to keep that in mind. But I know we're running out of time. Again, I want to thank you for letting me present. I really enjoy it. I think this is a great organization along with Partners for Clean Air, and you guys keep up the great work. It's been a great conference so far. You have done a fantastic job. Thank you so much.
Thank you.
Thank you, Michael. Great to see you, and thanks for the excellent message. We really appreciate it and appreciate the partnership we have with you in Northern Indiana as well. And we know we're going to get to your facility at some point with our partners meeting, so we're excited about that too. So we are running right on schedule, so I just want to remind all of you that following today's final session, which we're about ready to launch into, you're going to get a survey, and it's going to ask you some questions. We just ask that you give us that feedback. Also, following this next session, we encourage you to visit our REMO site, and I'll talk a little bit about that at the end of this final presentation, but it's really an opportunity for you to network one more time, and it's where we will end up our day's program with some door prizes at the end, so make sure you're in Remo at the end of the day as we adjourn at 4:30. So we certainly appreciate that as well. Really, our next session is about to begin, and so we're gonna just move to that. Our final presentation of the conference is talking about MPDS stormwater program updates and compliance tips. And we have two speakers, and I'll introduce each of them, and then they are going to tag team the Q&A at the end. So we're going to move into introducing Randy Braun. So Randy Braun is a certified professional in erosion and sediment control and municipal stormwater. He is a graduate of Purdue University and has a BS degree in natural resources and environmental science. He began his career in the Department of Natural Resources Division of Soil Conservation in 1980, and he is currently the section chief for the Wetlands and Stormwater section here at the Indiana Department of Environmental Management. His responsibilities include implementation and oversight of MPDS stormwater regulations related to construction, industrial, and MS4s. He also manages the 401 water certification and isolated wetlands regulatory programs within the agency. I personally have worked with Randy for over 20 years, consider him a great friend, and know that you will obtain a lot from his presentation. So we will play his presentation now.
I'd like to introduce myself. My name is Randy Braun. I'm the section chief with the Wetlands and Stormwater section within the Indiana Department of Environmental Management. I will be co-presenting with Lori Gates of Christopher Burke Engineering. Before I begin talking about industrial stormwater, I'd like to give an update of a current process at IDEM. We're looking at our promulgated rules and moving towards master general permits. Some of the reason for this change are potential conflicts with that approval process for those administrative rules, and we're also not current with US EPA regulations. The process is going to be taken for each of the stormwater permits: construction site runoff, municipal separate storm sewer systems, and industrial stormwater runoff. Our stormwater rules were last updated in 2003. When we began the process to draft general permits, we based this on our experience in implementing the 3 stormwater regulations, and we also took into consideration US EPA's current versions of the construction general permit, the MS4 general permit, the EPA remand rule requirements, and the industrial multi-sector general permit. When we began the general permit conversion process, we established procedures to issue each permit. Initially, we draft a permit and submit that draft to EPA for review and comment. Once we receive comments back from EPA, we assemble an advisory group. The purpose of the advisory group is to have discussions about that draft permit, and as we go through that process, incorporate changes. Upon completion of that process, we submit a final draft to EPA for final review and concurrence. Upon receiving concurrence from EPA, we public notice the final permit. At this point in time, we have concurrence on the construction site general permit. We are getting ready to submit the MS4 general permit to EPA for final approval, and we have a draft of the industrial stormwater permit. I'd like to begin talking about the industrial stormwater program. The program is administered under 327 IAC 15-6. Facilities that operate under specific standard industrial classification codes or meet the narrative requirements that are in the rule and also have discharges that are associated with a point source are required to obtain permit coverage. There are several exclusions that appear in the rule, one of these being no exposure. The second is no discharge exclusion, which is related to the absence of a point source. Just a brief overview of no exposure. This is a certification by the operator that industrial materials and activities are protected to prevent exposure to rain, snow, snowmelt, and runoff. The second of the exclusions is a no discharge exclusion. The operator of a facility must demonstrate that runoff from the facility does not discharge through a point source. If a facility meets the eligibility requirements to obtain permit coverage, the facility must submit a notice of intent. Permit coverage for an initial NOI submittal begins the day IDEM receives that application. If the facility is renewing coverage, the coverage begins from the previous permit cycle date. In the first year of permit coverage, there are specific requirements that must be met. In addition, this first year of permit coverage is an opportunity to completely evaluate and assess on-site operations and the facility. These requirements include developing and implementing a stormwater pollution prevention plan, conducting annual sampling, conducting quarterly visual monitoring. In addition, submit a stormwater monitoring report. This first year of sampling is an assessment tool in developing the stormwater pollution prevention plan, but also a sampling baseline for subsequent samples that will be taken in years 2 through 5. You must submit a stormwater pollution prevention checklist that certifies that the stormwater pollution prevention plan meets the requirements of the rule. In addition, an annual report must be submitted. The stormwater pollution prevention plan must be representative of all operations and activities that occur at the facility, including infrastructure. The overall purpose of the plan is to identify pollutant sources, especially those exposed to stormwater. The facility operator must develop and implement practices and measures to reduce or eliminate exposure. Eliminating exposure to stormwater is one of the key elements in achieving compliance. In addition, where exposure cannot be eliminated, the facility operator must implement treatment control measures to eliminate or reduce the discharge of pollutants. The Stormwater Pollution Prevention Plan is a living document. Therefore, the facility operator must reevaluate the effectiveness of existing preventive treatment practices and measures. After doing a thorough evaluation and development of a stormwater pollution prevention plan in the first year of permit coverage, the facility operator for years 2 through 5 of the permit must continue to implement the stormwater pollution prevention plan and modify that plan based on industrial operations and sampling. In addition, continue to conduct annual monitoring and quarterly visual monitoring. Based on sampling results and observations, make modifications to operations and/or install appropriate stormwater management measures based on the sampling results. And finally, submit an annual report. The monitoring program requires samples to be taken from each outfall designated on the NOI. Upon submittal of an NOI, a facility operator may claim that outfalls are similar. A similar outfall is one that has similar industrial activities within the drainage area of each of the outfalls. Samples must be collected annually. The annual sample is based on the permit start date. For example, if a permit begins on April 15th, 2021, the first sample must be taken between April 15th, 2021 and April 14th, 2022. All samples must be from a measurable rain event of 0.1 inch or greater and at least 72 hours from the previous measurable rain event. The sample must be taken during the first 30 minutes of the discharge at the outfall. The rule requires specific parameters to be sampled for. Those are listed on this slide. The facility operator should also identify any potential pollutants that may be associated with their SIC code or their operations on site. In addition, when IDEM conducts an inspection, there is a possibility that the inspector may identify potential pollutants and may require additional parameters to be sampled for. The quarterly visual monitoring program and annual sampling are key elements to achieve compliance with this rule. The rule requires comparison of sampling results from one year to the next in an effort to achieve parameter reductions. If reductions are not met from year to year, the operator is required to either make modifications of their operations and/or install additional measures to meet these objectives. The rule implies continuous improvement, but does not establish reduction thresholds. Since the rule does not establish reduction thresholds, and IDEM has been asked by permittees about this specific issue, IDEM has developed guidance of what we believe to be reasonable goals in achieving a reduction in parameters, and this is based on US EPA benchmarks. IDEM recommends the facility operator use these benchmarks to assess management of the facility. Discharges above the benchmarks are not necessarily violations, but an indicator that operations at the facility warrant corrective action. In addition, some of the common problems found when doing regulatory inspections are that the stormwater pollution prevention plan is out of date, the facility has failed to perform sampling and/or quarterly monitoring, there has been an unauthorized release or discharge, and that control measures are not properly operated, maintained, or installed based on sampling. Rather than take questions at this time, I will defer to Lori Gates, and we will take questions at the end of her presentation.
Thank you, Randy. So our next speaker is Lori Gates, who works for the Christopher B. Burke Engineering, LLC, and she has been there since 2003. She has a bachelor's degree in biological sciences from Indiana University, and in her professional role, she is responsible for stormwater regulatory compliance for water resources and environmental projects. She has worked with over 75 MS4 entities in several industries throughout the state of Indiana. She works to ensure that all municipal, construction, and industrial stormwater quality projects and permits are in compliance with state and federal regulations. We welcome Lori to the P2 conference. We will share her presentation now.
Hello, this is Lori Gates with Christopher Burke Engineering. For part 2 of our presentation today, I want to kind of pick up where Randy left off, talking about some of those good tips that he just showed us in his presentation about what IDEM inspectors are looking for when they do industrial stormwater regulatory inspections. So by taking these 4 bullets that Randy mentioned, these are non-compliance kind of issues, we can improve what we do day to day in implementing the industrial stormwater permits. So what I did is I took those 4 bullet points, and you can see across the top, this will be kind of our rolling agenda for what I will be speaking about, where we look at the stormwater pollution prevention plan, the sampling and monitoring, an unauthorized release or discharge, some potential BMPs, and then the what else, because there are a few additional items for permit implementation that we need to consider. So the first thing there, and you can see I have in quotes the statement from Randy's slide, and we have our handy dandy Randy bullet. So each time those appear, you'll know that's from that slide, taken exactly as he phrased it. So the SWIP, he said, is out of date, is very common, and also said that the SWIP needs to be a living document. So the SWIP will have several things identified in it. Your stormwater pollution prevention team, that's a really common area where you see a lot of staff turnover. So you have to identify your team members. Now these can be identified either as an individual, a person's name certainly could appear there, or you could put a person's position. Either one, IDEM would still need to have those specific individuals' names for when they do an on-site inspection or audit of some type. Also, exposed materials that are there can also change over time. So let's think about what is the purpose overall of the SWIP. If we take a step back, the intent of this is to be a roadmap overall for program implementation. So that's why Randy is saying this is a living document, because if we don't have a current SWIP, how do we know what we're implementing for our permit, or maybe what needs to be revised or what would need to be changed over time? One thing to think about too with the SWIP is it really helps if we put as much information for a SWIP on a map or some type of visual document as possible, because it makes it easy for us to orient to the information. So you can take an aerial map such as this. This is a small airport facility. Label the buildings, label the potential pollutants of concern. Certainly the stormwater and sewer, sanitary sewer infrastructure should be identified on this map, as well as your outfalls and the direction of the stormwater flow. A lot of that information that you're asked to show needs to go on the map. And it could be, maybe you do a handful of exhibits with it so that your maps don't get too cluttered, would be a good way to approach this. So Randy had mentioned, and we get this question a lot about the SWIPs, like when do I need to update it exactly? People get confused. So there are certain triggers that I would say, it's always a best professional judgment call, but certainly example triggers that you should use for updating the SWIP with any additions or deletions that you would have. So the first one there, any changes at the facility that you have. Facilities often undergo expansions. There could be a closure. There could be maybe an outfall that's changed at your facility. Maybe your representative overall outfall has changed. Changes in operations. Maybe some of the processes. Maybe you changed how you're doing your shipping. Storage, where things are stored, and different types of chemicals maybe that are stored. Have we gone from liquid to dry product, the type of products that you use? What about changes in staff or staff positions? Very common to happen. You could have, for example, the team that we talked about previously, you could have positions listed maybe in the SWIP, and then you have a supplemental outside document where you have specific individuals' names, and maybe you can keep that updated a little easier. There's several different ways to approach this, so always be thinking outside of the box. Your best management practices, your BMPs, aren't working. So here we either need to substitute something, or maybe we've added some additional BMPs. So any kind of changes like that definitely include. Your facility inspection reports, some facilities will include those as part of that document. It's easiest maybe to keep them in a separate folder, but always they need to be kept someplace where you can easily find them, and definitely need to be kept up to date as part of that SWIP. The SWIP update frequency, we mentioned a trigger from the previous slide, but when you get to the actual when, time-wise, think about when you prepare your annual report to get that information and to have that be meaningful information. You always need to do an annual review. It's almost, I would say, like a mini audit of your program. So that should be done in conjunction with preparing that annual report material that's needed. At a bare minimum, and I'm talking absolute bare minimum, let's say nothing's changed at your facility, I would still update that plan at least once every 5-year permit term. Even if you just change the cover, you're changing a date, you really need to review the plan as well. But when that date is updated on the cover, it shows that, hey, we have reviewed this, we have looked through it, and it is up to date. So one of the tips I would give you is, as a permittee, we always must plan for updates. Since Randy has said this is a living document, it's logical to think, oh, this will need to be updated periodically, and I need to plan this as a calendar type event to have it updated. Randy also mentioned failure to perform sampling and/or quarterly monitoring is an issue. So yes, we need to sample for all the parameters that are in Rule 6 that are specified with our annual sampling, plus whatever is reasonably expected to be in the discharge. Facilities often struggle with, well, what does that even mean? And what additional parameters do I need to come up with? You don't need to guess. My tip is use the EPA multi-sector general permit and resources, because it will show you for your particular industrial sector what you need to monitor. So here's an example. This is a page from the actual multi-sector general permit that EPA has. So for example purposes for this presentation, I just picked the first sector of industry that appeared there. So in this case, it's the timber industry. And this is where the multi-sector general permit is a really nice tool, because EPA has taken various sectors of industry that are regulated by the permit, and they've created specific information for that industry. So you're not trying to do the exact same thing that another type of business that is totally unrelated to you would do. So in this example, where it comes to the, well, what do I monitor for? The multi-sector general permit tells you, and they tell you specifically for your industry. The other nice thing they've done is they give you generalized benchmark monitoring concentrations, because people are always wondering, what values, or when I get my report back from the laboratory, what does it even mean? How do I interpret that? So this will give you an idea of, and keep in mind, when we're talking about EPA here, this is data from all across the country, and there are a lot of variables here. So it's just meant to be a very broad kind of generalization where I can at least have something to compare myself to see if I'm even within range or my numbers way off. And those should indicate to you that you need to, maybe if your numbers are way off, maybe you need to choose some different BMPs for that data. But going back to these sector-specific benchmarks, and then also the monitoring parameters, those are all listed out actually in the permit. The other neat thing that EPA has is a very nice series of industrial stormwater fact sheets. So here's the one, again, for timber industry, where it would talk about, what is the permitting program, and then what kind of, facilities need coverage, and then it goes on there to include things like, what kind of pollutants are associated at my, facilities. So when we look at the multi-sector, general permit example, here again, you can see in the fact sheet, there's a table that talks about, here are the various pollutant sources at my facility, and then the potential pollutants that are there. Not saying that they'll always be there, but we just need to keep in mind, we plan our BMPs to address these particular pollutants of concerns and these particular sources. Also, in talking about sampling and monitoring, I think we need to think about receiving water quality, because more and more in our state, the TMDL program, Total Maximum Daily Load program, is developing. For you guys that aren't familiar, IDEM does different types of monitoring. They do a 305B, and these numbers are based out of the Clean Water Act. They do 305B monitoring, which is their basin-wide monitoring, and then any of the parameters that they monitor for a particular stream reach of a water body, if these don't meet state water quality standards, then these stream reaches are placed on a 303D list for these parameters of concern. So the 303D list is considered the impaired water bodies list. So it's very important to know if your facility discharges to a 303D stream, because eventually when a stream reach is placed on the 303D list, then a total maximum daily load plan must be developed. And that's where that plan establishes pollutant loadings to that particular stream reach. And that eventually those kind of loadings and limits will be translated into your MPDS permit in some fashion. Usually for stormwater general permits, it's done on a BMP's management kind of basis. Here's an equation down at the bottom for how a TMDL load is determined. So you take your waste load allocation, which are your point sources. The waste load allocation are anything, and point sources in EPA language is anything that's regulated by EPA. So this would include industrial stormwater, municipal stormwater, construction stormwater, and any of the other MPDS permits could be under this. There's a load allocation, and there's also a margin of safety there. So for the second part of what Randy had discussed, is the quarterly monitoring. So he mentioned failure to perform quarterly monitoring was a problem. This is your visual inspection. Part of the forms that IDEM have for the annual report allow you to record, yes, I completed an inspection on this day. However, there is no form, state form, for actually doing this quarterly inspection. So you need to come up with your own. You don't need to totally invent it yourself, because there are some really good examples that are out there. So here's an example on the slide where on the right hand side here, just very simple. So you want to list things that are specific to your site, that cover your grounds, inside, outside, and then decide, is it okay? Do I need a corrective action? Is there a potential problem here? And then RS means I need to revise my SWIP, because these inspections drive how your SWIP is revised. Here's another example of a particular form for inspections. This is EPA's form, one that they use, where you're looking at material. Is it inspected? Were your controls appropriate, effective, operating? And then either maintenance or corrective action is needed, and some type of notes. So note on the two examples we've seen of quarterly inspection forms, there's a slot on there for corrective action is needed. This is one thing that I know that EPA IDEM looks for when they do an audit or inspection of a facility. So make sure, and I strongly advise that you and recommend that you have an inspection form. You fill out these inspection forms quarterly, because you will be asked for them, and make sure that form has a place for recording corrective actions. Here's another example Wisconsin DNR has developed, where you start to look at things like color, odor, clarity, and floatables, deposits. There's another really good example of a form from Center for Watershed Protection. So there's plenty of examples that are out there. Create a form that works best for you. So a word about conducting facility inspections. I'll go through the 4 areas of your facility that you need to take a look at. Make sure that you keep a photo summary of your inspections. So even if you just keep these photos for internal use, it's great training that could be utilized later. You can also take great photos of before and after examples. So say one is, oh, we identified a problem here. This BMP is failing. So the after photo should be, here's how we corrected that and took action. And also practice potential audit questions that you might have with IDEM, or say if an EPA inspector would happen to come on site. Or also, if you're located in an MS4, Municipal Separate Storm Sewer System area, the MS4s can ask for facility inspection records. They can ask for your SWIP as well, because those are public documents. The 4 areas to worry about with your quarterly inspections: make sure you look at your outer perimeter, your facility yard itself. You need to look inside your building, and then also all the paperwork, the procedural documents will be checked as well, need to be checked on a regular basis. So for the outer perimeter, you're looking primarily to see where and if that contaminated runoff or runoff at all goes off of your site. So these are your outfalls, or remember, stormwater, water traveling, leaving your site is going to find the path of least resistance. So sometimes that stormwater will create its own outfall or place to leave your facility property or boundary. In Clean Water Act terms, these are the most serious kind of violations where you have contaminated stormwater and it's leaving your site, it's getting into a water of the state. So always make sure that you check your outer perimeter because that's your last line of defense, essentially. Make sure that perimeter is adequately maintained and that your discharge release points are functioning properly and are maintained. The facility yard itself, your stormwater conveyance, you should have this identified on a map and know. We recommend marking, labeling. You could do signage. What's a stormwater inlet versus what is a sanitary type inlet? If it's a refueling area, for example, dumpsters, roll-off containers, are they covered, not leaking? Do you have stockpiles in your yard? These are just some examples of what could be out there, and it could change depending on what your operations are, of course. For the building itself, when we're inside, we're going to check any building drain kind of best management practices we have, vehicle maintenance, BMPs, liquid storage, dry material storage, things associated with your processes. These are just some examples. And then with the procedures, is your SWIP updated and readily available, as well as your visual inspection forms done quarterly? What about your MSDS, SDS sheets? Are they available? Any type of maintenance documents or records? Say you have an oil water separator or some other type of BMP that receives regular maintenance, whether you do it in-house or you hire an outside contractor, make sure you keep maintenance records, because it's not enough to say, oh yeah, we had that maintained. You need to prove it to when it was last done. Randy also mentioned an unauthorized release or discharge. So unauthorized release is more of a temporary, short-term episodic type of event. Could be a spill, a leak. You need to be prepared for those. Could be an illegal dumping of some type. Washout waters is an example. Unauthorized discharges tend to be more long-term, chronic type things. So maybe you have an inadvertent cross connection with sanitary sewer. I went to a facility one time that made copper wire. Couldn't figure out why they were getting high hits of copper in their stormwater sampling. They found out they had an employee hand washing sink actually connected to the separate storm, which of course is a big no-no. Maybe you just have a high groundwater table in the area, so you can get interference with that sometimes. So it's important to figure out what those particular discharges. The bottom line is keeping those pollutants on your site and out of water features, because as I mentioned, your MPS permit is issued to the perimeter of your site. So when it leaves your boundary, that's when it's problematic. Here's a way to track, and you do need to track if you have some type of non-stormwater discharge. So again, come up with a form. It can be very simple, and then record some of the characteristics of that particular discharge. And then I think the important thing is that last column there. What was the date that it was corrected? You could take photographic evidence of this and then also add more comments to a form. This is a very simple example of a form. Certainly you'd want to flesh this out a little bit. Here's an example of an unauthorized release or discharge. I apologize for the fuzziness of the images, but they were taken a while ago. There was a particular example where there was a novelty ice cream manufacturer, and they were cleaning out a freezer, and then the local municipal wastewater staff, they were getting calls saying, oh my gosh, there's a creek and it's bright red. Where is this coming from? So the pretreatment staff got out there. They traced it upstream. Yep, they found more. You can see that picture on the right top there, more of that red discharge. And then they found the facility where it was coming out of. What happened was they were cleaning out their freezers that day, and they had some red popsicles, and they were just thrown right into the dumpster. And what do you know? It caused a big unauthorized release at that particular time. Best management practices, BMPs, Randy mentioned your control measures or your BMPs are not properly operated, maintained, or installed based on sampling that you would have. So there are different types of best management practices. There are non-structural BMPs that you should have. These would be policies, procedures, plans, training, communication, and then also structural BMPs. These could be filters in your storm inlets, berms to help manage the runoff, keep it on site, secondary containment structures, spill kits, for example. There's always, I mentioned the great BMP's misnomer. So these are called best management practices, and I think there's a presumption there that, oh, I choose this practice, this is the best thing for my site. Well, no, you have to remember a lot of BMPs are based on best professional judgment, and we don't know a lot of times if they're going to work until they're actually on site at your facility and you try them out. So a lot of this is trial and error. This is why we say you need to go back, inspect, and monitor and check to see if those BMPs are working. Because there's a bunch of different types that are out there and you could always use something else. Here's an example of non-structural BMPs. So the process that I chose to highlight here is your stormwater assessment process example. So you've got your visual checklist that you do quarterly. So that needs to be tied in. You could use a log to say, okay, here's how often I did my visual monitorings and what I found. And the most important thing is, based on my findings and any corrective actions that I have, do I now need to revise my SWIP? Does that cause a trigger? So somehow you need to connect those visual inspections with revising your SWIP, and this is just one way to do it. Here's another example of a non-structural BMP, an organizational chart. Who does what related to permit compliance and implementation? There's all the things that you have to do to implement a Rule 6 permit, and then who's going to do it. These are great communication documents to have, especially in the case of an audit. If you have to produce this information quickly, this gives the inspector a very quick visual orientation as to what is going on at your facility, and it produces a really good impression of your facility because it shows that, oh yeah, we are organized on our permit. We have very thoughtfully thought about how to implement this, and we do implement it on a regular basis. Here's some examples of structural BMPs. So we go back to our EPA fact sheet on the timber industry, and based on your type of industry, and EPA has developed these for each of the sectors identified in their multi-sector general permit, and then it lists different types of BMPs based on the pollutant source. So you're never at a loss to think of, oh, what type of BMP do I need to use at this particular facility? So here's an idea on where to find BMPs. The other thing is sometimes you need to consult a BMP provider or your friendly, like me, stormwater consultant. We'd love for you to use us as well. So sometimes figuring out what you need, like I said, trial and error, and there are a lot of different types of use out there. Also, the what else. So we know that we need an annual report. This is due 365 days from your NOI submittal date or your previous submittal. And IDEM does have a form for this. So don't forget to send in these documents. It's very important to have a good impression overall on your annual report, because sometimes this is the only visual that IDEM has as far as an insight to how well you're implementing your program. So you always need to want to provide and always need to provide a thoughtful annual report. Also, there's an annual and ongoing staff training requirement. So we always get the question of who needs to be trained. Well, anybody that's directly involved with implementing your stormwater program, whether it's a full-time employee, a part-time employee, new hires, seasonal, interns, if they're involved with something in some way, shape, or form that could potentially adversely affect the quality of your stormwater discharge, you need to be training those people. Does everybody need the same level or technical or amount of training? Absolutely not. You definitely want to vary your topics based on who those staff are and what they're involved with. What if you're behind on training? This is a very common problem that I run into with clients, and that is you want to get something scheduled and then be prepared to submit a training schedule, compliance schedule to IDEM to show, hey, I recognize this is an issue, here's how I'm going to fix it. Annual and ongoing, where can you send your staff for training? Yeah, use your friendly stormwater consultant like me. You can use videos, there's a lot of those out there. Commercial lunch and learns, field visits, webinars, magazine articles, meetings, professional organizations. There's a lot of resources that are out there. So also think about long-term professional development. And Envirocert International, the last bullet that's listed there, they now have a certified professional in industrial stormwater program. So you have to have a certain level of experience to bring to that, and then you take an exam that demonstrates your level of knowledge. So check out Envirocert International's website to learn more about that. Resources. So to kind of wrap up here, I want to show you some of the different resources that are available there, because people sometimes just don't have a clue. They're not as familiar with industrial stormwater as those that have done this for a long time. So for each of the bullets that are listed here, I've got some follow-up slides and comments. We've got EPA, they have a SWIP guidance document, a sampling guidance document, a no exposure guidance. They have, I mentioned the industrial stormwater fact sheet series, and then also there's a Printers National Environmental Assistance Center. So here is the EPA SWIP guide for operators that you can use. Has good information about developing your SWIP, including, we mentioned, showing a lot of information visually. So here's an example diagram with a legend to show you all the different types of things that could go on potentially your visual maps, your diagrams that you have there. A great way to communicate information easily and quickly. There is a industrial stormwater monitoring and sampling guide that's available. Also, for people that think they meet a condition of no exposure, there's a guidance manual there that you definitely will want to review and check, as well as EPA's no exposure form has some general recommendations or guidelines for whether you qualify for no exposure. But in addition, you definitely want to go through the guidance manual to make sure you meet that condition. Here's the Printers National Environmental Assistance Center. You can see they have a permit guide that's here, and they provide different lessons on stormwater, decision-making trees, photo galleries. So this could be quite useful to you as well. So that's the conclusion of my presentation, and now Randy and I will be glad to take any questions that you guys may have. Thank you for your attention.
Thank you so much, Randy and Lori, for sharing information about the MPDS stormwater programs and offering those compliance tips. It looks like our Q&A box is full, and if we just ask that if you have additional questions that you type them in the question and answer box at the bottom of your Zoom screen. Assisting us with moderating our Q&A for the last time for our conference is my colleague, our partner, an executive committee member for the Partners for Pollution Committee, who is the manager of our Pollution Prevention and Technical Assistance Program here at IDEM. I'm going to introduce to you Jennifer Collins, and she'll moderate the questions.
Thank you so much, Julia, and welcome Randy and Lori to our question and answer session. Thank you so much for presenting today. And we do have lots of questions for you, so we'll go ahead and get started here, and we'll see how many we can get answered in this time. So our first one is related back here to quarterly monitoring and site inspections. What is the intention for these and a tour of the outfall location, a site tour, or other.
I can go ahead and start with that, and Lori wants to add in.
Okay.
Basically, it's a quarterly visual monitoring program. So basically, you only sample once a year, standard requirement of the industrial stormwater permit. So really, the quarterly visual monitoring is to make an assessment of your facility during your operations. So it's more of a checking things to make sure things are in order. And you're not only you're doing a visual of your discharges, but you're looking at your management practices, like Lori described some of those practices. Are they functioning, that type of thing? Are you maintaining them? It's to really do a check of your overall facility that you're operating. If you're under no exposure, you'd be checking to make sure you're maintaining your no exposure certification.
Excellent.
And usually I tell my clients that, you know, it's a great opportunity for you to catch those small things before they become much bigger problems.
Great. Good advice. Okay. Our next question is, if your site has multiple outfalls, it is very difficult to get them all sampled within the first 30 minutes of storm initiation, recognizing that the regulation states, or as soon as practicable. There's no upper end duration for this. What is the longest duration that is acceptable?
I actually haven't heard this before, in this kind of question, but a lot of our facilities don't have that many outfalls, but we do have some that have quite a few. There's quite a few facilities. There's a few facilities that have quite a few outfalls. I think the facility could we have one facility has over 100 and some outfalls. And I know they have put together kind of an operational plan where they have multiple people grabbing those samples. I think you would put a plan into place if you can't make that threshold, that time threshold. I would probably pull the samples on probably the outfalls that have more potential to discharge pollutants, so you get an more accurate reading on what's really coming off your facility. I would prioritize those. We are going to a new general permit, so that may be something we want to look at, is trying to put some kind of provision in to address that question.
Sounds like a good idea. Lori, did you have anything for that?
No, that sounds good. Thank you.
And another question regarding valid storm events. 0.1 inch of precipitation per NOAA records can be achieved with a day-long drizzle. Still, the actual discharge is nominal. How should this be managed with regards to qualifying it as a valid event, particularly with the 72-hour dry spell in advance of sampling? I believe that 0.1 inch of rain over an hour or another specified duration is a more suitable qualifier.
Actually, a tenth of an inch is the threshold, so I'm not quite sure what the question is.
Yeah, there wasn't really a question there. That was so. If
Comment.
you have more more information to add to that, please feel free to insert more of a question.
Well, and keep in mind too, with that requirement, it's when the outfall discharges. So I think, Randy, right, there's a presumption that there's discharge from that outfall.
Yeah, actually, that's a good point, because you know we'll have some facilities contact us. If the runoff's going right into a pipe, then it's going to happen a lot quicker. We have facilities though that actually discharge through a basin, and their outfalls at the end of that basin. So it may not discharge in that time period. So it's when that discharge first occurs. So we have some facilities that it could be hours before anything goes through that discharge point in their basin. And that's when they would actually grab that sample at the basin. It's when it discharges through that outfall. That's a good point, Lori.
So this question is, for a facility that has had a Rule 6 permit and implemented BMPs for many years, What is your guidance for meeting the requirements for continuous improvement when the annual analytical results are consistently low, but fluctuate up and down some from year to year?
We, in Rule 6, there really is no standard to achieve. And we've actually been providing the EPA benchmarks that are going to be, that are from the multi-sector general permit, EPA's multi-sector general permit. We actually provide those and try to get facilities to use those to kind of measure how well they're doing. And we do see spikes. And when we do see a spike, our typical approach would be to contact the facility. They've done pretty well, and all of a sudden they have a spike. We'll actually go back and ask about their quarterly visual monitoring, or ask them, has something changed at your facility that you're aware of that would potentially trigger this? We had one facility, their pH went up, skyrocketed, and we actually traced it back to them replacing the riprap in their outfall, and they grabbed the sample like the day after the new rock went in. So, and we saw a little increase in total suspended solids too. So we traced it back to a modification of a practice. And, you know, after the time they grabbed their next sample, they volunteered to take a sample at the next qualifying rain event, and the numbers were down. So sometimes it's just those little things, like Lori said, to look for those little things that happen on your site or your facility that could contribute to some of those issues.
And something a facility like that might want to think about is have a third-party audit, almost a friendly audit, if you will, conducted, because that's a good test as to how you would do if that, you know, IDEM or EPA inspector would show up.
Absolutely, yes. So regarding SWIP requirements for monitoring data evaluation and associated requirement to investigate / correct is unclear. If parameters do not have permit limits, sample only, when doing the evaluation, what criteria should a site compare the results to determine if an investigation is warranted?
Not quite sure I understand the question.
Does that make sense?
It doesn't make, I'm not quite sure what they mean by what they're after. Did you catch it, Lori?
No, I'm not, sorry, I'm not following that either.
So regarding SWIP requirements for monitoring data evaluation and associated requirement to investigate or correct is unclear.
And it could be going back to the continuous improvement a little bit. I mean, and you're only sampling once a year. So I could see, it's that thing again, if you see a spike in that sampling, then you need to investigate it. That's the only thing I can think of. And, you know, I really think that quarterly visual monitoring is a big one in here, and looking at your day-to-day operations. In fact, probably quarterly visual monitoring is what's required, but I know of a few facilities where they have a more intensive program in place where, you know, they walk those facilities once a week to make sure that everything's being operated the way it should be, to avoid some of those problems. So
that makes sense.
You know, it's kind of increasing that to make sure you don't get in trouble, being aware of what's going on at the facility. You know, the sampling and the quarterly monitoring are just tools to help you, but internal programs where you can be a little more aggressive, and just knowing the day-to-day operations and what's going on at your facility can make a big improvement.
Yes. And it's a living document, remember? Need to keep track of that. Let's see. Stormwater observation requirements for color, clarity, odor, floatables, foam, etc. If it could, I'm not sure where that started. If a concern is documented on the observation form, at what point is the site required to report that observation? recognizing that a heavy oil sheen has a separately reporting requirements. So I think the question is, if a concern is documented on the observation form, at what point is the site required to report that observation?
I'll let Lori chime in too, but first, if you discover that, it should be in your quarterly visual monitoring report. And then the immediate thing would be to investigate where it's coming from. If it was a spill and you're required to report that spill, you should report that spill. But the next step was what corrective action you're going to take. And the rule isn't real clear on a response time to do that, but you know, that should be investigated immediately into trying to find out where the source is.
Lori, did you have anything with that?
Yeah, I think so. But and keep in mind, there's a difference between that you're recording internal data to try and identify potential corrective actions versus truly what has to be reported. I don't know if this is trying to get at, you know, spill and spill rule requirements, but this is part of the information that you would keep internally primarily.
And really, the basis of the general permit is for you to manage your facility. That's why you're under a general permit. There's general guidelines, and it's your responsibility as a permittee to manage that facility, those operations on a day-to-day basis.
Yes. Okay. This is from Eric Foster. If your facility discharges to a stream that is impaired, are you required to sample your stormwater for the parameters for which the stream is impaired?
Actually, we're not requiring that right now because we're not collecting some of that data. When we enforce the TMDL and 303D list program in the next permit, we'll be looking at those issues in more depth.
Okay. And can you please summarize the differences between the draft industrial stormwater permit mentioned and the existing Rule 6 permit by rule?
The differences?
The key differences.
Key differences. Well, I think what we're really looking at is, and we're working on a draft right now. We are looking at the federal multi-sector general permit. So that's an indication of the direction we're going. The permit hasn't been updated since, or the rule hasn't been updated since 2003. There's been a lot of changes at the federal level, and we are looking at that multi-sector general permit. We will be permitting by sector or identify. You'll submit your NOI, and it'll be based on the sector or sectors that your operations fall within. So I'd say there could be some fairly significant changes just because we haven't updated anything since 2003, and the multi-sector general permit is a lot different than what we're dealing with now. The nice thing about the way the multi-sector general permit is set up, it's more directed towards your industry or what your industrial activities are. You know, right now you sample for 8 parameters. You may not have some of those 8 parameters might not even be associated with your facility. So the nice thing is it's more directed towards what your facility actually does and what your industrial activities are.
Okay. Yeah, a lot of changes to come. We have a lot more questions. I think we're down to a 2-minute warning here. So let's see. We've answered some of these already. Someone would like to know what triggers an on-site inspection by item or EPA. Are these routinely done? Along with that, there is a question that says, what inspection resources has item allocated, and are there plans to change inspection frequency?
We basically, we get the monitoring data in the sampling. We basically evaluate that, and then if there are high levels of a constituent that we see or something that's high levels of discharge, like TSS is very high, we'll put that facility on an inspection list. We also we go to an area, say we go to a county and we have a couple of facilities to inspect, we'll probably pull our database up and look to see what other facilities might be in the area in that county. So we base it on what the sampling data is, annual reports, that type of thing. We try to get a mix between those with permit coverage and those with no exposure. So we also try to look at the no exposure facilities that have no exposure exclusion. And I don't see much change. We try to balance the staff that does the construction inspections are also the one doing industrial. So we try to balance that workload a little bit, and based on the volume of permits we have.
Okay. I think we could probably answer some of the other ones in the by typing the answers. And if I guess there's one other one I guess we'll answer live here is, if you have a private audit, do you have to report the findings to IDEM or EPA?
No, it's
No.
it's no, we're not
Lori
required.
says no, and Randy says yes.
No, if you'd like to, that's fine. No, it's not required. We don't require that. And, you know, we do from facilities talking about they're having a third-party audit or something like that. And sometimes they ask questions. They just want to make sure everything's in order. One of the biggest questions we have is they don't have a copy of their permit on site. Well, it's a permit by rule. So 327 IAC 15-6 is actually there, what they have to do. So that's probably the biggest question we get when there's a third-party audit. They get a little concerned that we didn't issue them a physical permit, which we don't do. So.
Okay. I think we'll answer all the rest of those in the chat if you two can answer those for us. And we thank you for your time again. And please look in the question answers for the remaining answers to these questions.
Great. Thank you, Jennifer. Thank you, Randy and Lori. We really appreciate your time today and preparing your presentations. All of these presentations that you've heard today and yesterday have been recorded and are going to be available on our Hay Summit site, and will be linked to our IDEM YouTube channel at some point in the near future as well. So we will certainly communicate all those times with you. Also, our attendees, this is our final session, so we really appreciate you sticking with us through the last 2 days. You're going to be getting an email with a survey link, and we just ask that you take the time over the next week to respond to that, and we really need your feedback to make future conferences and future events that our P2 Executive Committee puts on meaningful and important to you. So we now have until 4:10 p.m., just about 30 minutes to take some time in our trade show. So we encourage you to visit the trade show one time. I know many of you have already been there, but we do have tables set up in our Remo platform that have names on them, so you can navigate to the table that you want to visit, and you can have a conversation with colleagues and share information at that point. When you arrive in Remo, you will actually get there by just going to the tab in the Hay Summit link at the top and click on that Remo tab that says Remo Exhibit Hall, and it will take you through your invitation to the Remo Exhibit Hall, and you'll be able to have live face-to-face conversations. So at 4:10 is when our Executive Director, Ben McKnight, will join us back in the Exhibit Hall for some live closing remarks, and we also will be awarding some door prizes. So make sure you're there and don't miss out. So for my part, I just want to say thank you for joining us over the last 2 days for our 23rd Annual P2 Virtual Conference and Trade Show. We know we have done this in a very unusual way, but we hope that it has been able to bring you a lot of great information and resources to make your personal lives and professional lives something that you're going to be able to utilize in both of those. So we look forward to seeing you next year at our 24th annual Pollution Prevention and Trade Show. We plan to be back in a hotel setting, and we'll be at the Marriott Indianapolis North on September 23rd, 2021. But we've got several events between now and then with our quarterly meetings and discussions that we'll have. But make sure and mark your calendars for September 23rd of 2021. At this point, I would probably say drive safe, but I'll just stay safe, stay well, and have a great fall. And we'll see you at 410 in the trade show. Have a great evening.